something extraordinary is approaching our solar system. A swarm of interstellar fragments is following the path of the famed comet 3IATLAS, racing silently through the darkness, carrying secrets from a star system light years away. What are these travelers? Where did they come from? And why are they moving together, as if guided by invisible threads across the galaxy? In this video, we'll follow their journey step by step. You'll drift alongside each fragment, imagining the faint glimmers of sunlight reflecting off icy surfaces, the subtle curves of their paths shaped by gravity, and the delicate tails of gas and dust that form as they near the sun. We'll explore the science behind their speed, their composition, and the cosmic forces that guide them. But this is not just a story of physics, it's a story of wonder. The swarm reminds us that our solar system is part of a larger, interconnected universe, where even tiny fragments carry the history of distant worlds. Settle in, breathe deeply, and let your imagination soar with these celestial travelers. This is Science for Sleep, a calm, mesmerizing journey through the cosmos, perfect for stargazers, dreamers, and anyone ready to drift off under the stars. A cosmic swarm arrives. The universe is a vast, silent expanse, stretching far beyond the reach of human eyes. A darkness punctuated only by the distant glow of stars. It seems eternal, immutable, and yet it is constantly in motion. Across unimaginable distances, cosmic events unfold, sometimes slowly, imperceptibly, over millions or even billions of years. And yet, once in a while, a phenomenon occurs that pierces our quiet night sky with sudden urgency. A visitor, moving swiftly, carrying with it secrets of a world far beyond our own. Tonight, we find ourselves witnessing just such an event, a swarm of interstellar objects racing into our solar system, following the path of the renowned comet 3IATLAS. The story begins with 3IATLAS itself, a trailblazing comet that captured the imagination of scientists and stargazers alike. Discovered in 2025, it was only the third confirmed interstellar object ever observed entering our cosmic neighborhood. Its hyperbolic trajectory, moving faster than any comet previously recorded, suggested a path that had begun far from our sun, in a distant star system, perhaps light years away. Its velocity alone, moving at tens of kilometers per second, marked it as extraordinary, a messenger from another part of the galaxy, slipping into our solar system briefly before continuing its silent journey across the stars. Yet now, astronomers have detected something even more intriguing. This comet may not have traveled alone. Following its trajectory is a swarm, a cluster of smaller celestial objects seemingly aligned with 3IATLAS, moving together through the void, tracing a path toward the sun. At first glance, these objects appear like fragments, small pieces of a larger cosmic puzzle. But the questions quickly multiply. Are these remnants of a larger body torn apart long ago? Could they be companion objects gravitationally bound to the same interstellar origin? Or are they entirely independent travelers, mere wanderers coincidentally sharing a similar trajectory? Observations suggest that these objects are moving at remarkable speeds, some potentially surpassing even the velocity of 3IATLAS itself. Their trajectories are hyperbolic, meaning that they are not gravitationally bound to the sun. They are on a path that will carry them past our solar system and onward into the infinite darkness of interstellar space. Yet, for a brief, fleeting moment, they enter our solar system, giving us a chance, a rare, almost miraculous opportunity to study them and unravel their mysteries. To the casual observer, the arrival of these objects may seem like a mere celestial curiosity. But to astronomers, this is a treasure trove of knowledge, a fleeting gift from the universe. Each fragment, each icy or rocky body, carries the chemical signature of its home system, the record of its birth, and the processes that shaped it. In these small, silent travelers, we find clues to the conditions in other star systems, the composition of planets and comets far beyond our own Sunday, and even hints about the processes that led to the formation of our galaxy itself. The discovery of the swarm was made possible by the latest advances in astronomical technology. Sophisticated telescopes and automated survey systems scan the night sky relentlessly, identifying moving points of light against the backdrop of stars. It is through such careful observation that scientists notice the first hints of these objects, tiny, faint points of reflection, moving with an unmistakable purpose. At first, it was difficult to distinguish them from the countless asteroids and comets that populate our own solar system. But repeated observations confirmed something extraordinary. These objects were not native to our solar system. They were interstellar. The moment an interstellar object is confirmed, it sparks a flurry of activity in the astronomical community. Teams of researchers quickly analyze its trajectory, calculate its velocity, and determine its orbital path. For a swarm, this process is even more complex. Each fragment must be tracked individually, each path carefully plotted, to determine whether they are related or merely coincidental in their approach. The calculations involve not just the gravity of the sun, but also the subtle influences of planetary bodies, solar radiation, and the solar wind. It is a delicate cosmic dance, where even the smallest force can alter the path of these wandering objects. As the swarm approaches, the solar system itself becomes a stage on which the universe plays out its intricate physics. The sun's gravity begins to assert its influence more strongly, bending the trajectories of these objects ever so slightly. Some may experience a heating from the sun's light, causing the sublimation of icy surfaces and the release of gas and dust, forming faint tails or comas visible only to the most powerful telescopes. Others, more rocky or metallic in composition, remain intact, reflecting light like tiny cosmic mirrors as they glide silently past the planets. For us, the swarm represents both a challenge and an opportunity. It challenges our understanding of the frequency of interstellar visitors, the dynamics of small bodies in the solar system, and the conditions in distant star systems. Yet it offers an opportunity unparalleled in human history, a chance to study material that originated far beyond our sun, to analyze its composition, and to glimpse the processes at work in other corners of the Milky Way. Each fragment is a story, a tiny piece of another solar system's history, traveling billions of kilometers to whisper its secrets across the void. And so, tonight, as we watch this cosmic procession unfold, we enter a story that is both ancient and immediate. We are witnesses to a celestial journey that began millions of years ago in a region of space light years away, now arriving to our neighborhood for a brief and fleeting encounter. We are part of a narrative that stretches across time and space, connecting our solar system to the wider galaxy, and reminding us that the universe is not static, but alive with motion, mystery, and the endless potential for discovery. As we settle into this story, allow your mind to drift with the swarm, to follow the path of 3IATLAS and its companions as they race toward the sun. Let the numbers and distances become shapes in your imagination. The forces of gravity and radiation become gentle currents guiding these celestial travelers. And as the narration continues, you may find your curiosity blending with calm, your mind opening to the vastness of space while your body drifts toward rest. This is the beginning of a journey through the solar system, through interstellar space, and into the heart of cosmic mystery. Revisiting 3IATLAS, the pioneer visitor. Before we explore the newly discovered swarm, it is essential to look back at the path that led us here. The story of 3IATLAS, the first interstellar comet that opened our eyes to the mysteries beyond our solar system. To fully appreciate the significance of a swarm now following in its wake, we must understand the pioneer itself, the celestial traveler that first charted a course across our cosmic neighborhood, bridging distant stars with the quiet edges of our sun's influence. 3IATLAS was unlike any object observed before it. Unlike the comets that orbit our sun on predictable paths, its trajectory was hyperbolic, an elongated curve that indicated it was not bound to our solar system. It arrived from the depths of interstellar space, moving faster than any comet ever recorded, its speed measured at tens of kilometers per second. For astronomers, this was both astonishing and unprecedented. No comet like this had ever been seen entering the solar system from another star, and its presence immediately demanded attention, careful observation, and rigorous analysis. When 3IATLAS was first detected, its faint glimmer was barely distinguishable from the myriad of distant stars in the night sky. Yet, as automated telescopes tracked its path, it became apparent that this was no ordinary comet. Its angle of approach, its velocity, and the subtle way it defied the gravitational pull of the sun all pointed to one conclusion. This was an interstellar visitor, a messenger from beyond, traveling across light years of empty space to briefly illuminate our corner of the galaxy. The discovery sparked excitement across the astronomical community. Researchers around the globe quickly mobilized, sharing data and observations in real time. Using a combination of ground-based telescopes and space observatories, they charted the comet's trajectory, measured its speed, and even observed faint signs of outgassing, volatile ices evaporating under the sun's heat to create a delicate, transient tail. The comet became a living laboratory, a natural experiment, allowing scientists to study material from another star system without leaving Earth. 3IATLAS was composed of a mixture of rock, ice, and cosmic dust, a combination that has been found in many solar system comets. Yet, in this interstellar context, it told a story of formation far beyond the sun's gravitational influence. Its composition hinted at processes occurring in distant planetary systems, where icy bodies and rocky fragments coalesced under conditions perhaps very different from those we know. Every measurement of its speed, its orbit, and its light spectrum was a tiny clue about where it had originated, how it had traveled, and what secrets it carried from the far reaches of the galaxy. Astronomers quickly realized that the comet's passage was brief, a fleeting window into the unknown. Objects like 3IATLAS do not linger in the solar system. Once they enter, they move swiftly, their hyperbolic orbits ensuring they continue outward, eventually disappearing into interstellar space once again. The challenge, therefore, was to observe as much as possible, to glean every piece of information before it vanished from view. Every subtle change in brightness, every deviation in trajectory, and every observation of the tail's composition provided essential insights into the nature of interstellar visitors. The story of 3IATLAS also highlighted the limitations of our observational technology. Detecting such an object requires not only precise instruments, but also the foresight to interpret minute data points correctly. Its discovery marked a turning point in astronomy, revealing that interstellar objects are not as rare as once thought. They are simply difficult to detect, moving at incredible speeds across the void, often unnoticed until they enter our observational window. As the comet traveled past the Sun, its behavior was studied in exquisite detail. Scientists documented its trajectory, noting how it accelerated as it approached perihelion, the closest point to the Sun, and how subtle forces such as solar radiation and gravitational interactions with planets affected its path. They observed the faint glow of its tail, composed of dust and gas slowly drifting away from its nucleus, pointing always away from the Sun under the influence of the solar wind. Each observation was carefully logged, adding a layer of understanding to our knowledge of interstellar objects. 3IATLAS was more than just a comet. It was a herald, the first confirmed visitor from another star system, and the standard against which future interstellar discoveries would be measured. Its presence reminded us of the vastness of space, the movement of objects between stars, and the incredible distances traversed by matter before it reaches our solar system. For scientists, it was a call to refine their instruments, to sharpen their predictions, and to remain vigilant for the next visitor that might appear from the darkness. As we reflect on 3IATLAS, we begin to see the significance of the swarm now following in its path. The Pioneer has shown us that interstellar objects can reach the solar system, and that these visitors can carry invaluable information from the galaxy beyond. Each member of the swarm, each fragment and icy body, will be compared against the legacy of 3IATLAS, its speed, its composition, and its behavior, providing a benchmark for understanding this extraordinary procession. So, as you listen tonight, imagine the comet's journey through the stars, the vast distances it crossed, the silent corridors of space it navigated, and the Sun's gravitational embrace that slightly bent its path as it passed through. Feel the quiet wonder of observing a fragment of another world, traveling at unimaginable speeds, bringing with it secrets written in ice, dust, and cosmic history. Let your mind drift with 3IATLAS as it moves through our solar system, the first of its kind, a messenger whose path will now be echoed by the swarm that follows, racing toward the Sun in a celestial dance that spans light years and eons of time. The swarm, who are they following? As 3IATLAS continues to hold its place in the minds of astronomers, a new, remarkable discovery has shifted the cosmic spotlight. Observations indicate that it may not have been traveling alone. Following in its path, a swarm of smaller interstellar objects appears to be tracing a similar trajectory, approaching our solar system with the same elegance, the same precision, and an almost uncanny timing. For astronomers, this is both thrilling and puzzling. A single interstellar comet is extraordinary. A swarm is unprecedented. Imagine, for a moment, the vastness of space. Even at light speed, the distances between stars are immense. And yet, here is a cluster of objects, each independently moving through interstellar space, all converging toward the same solar neighborhood. It's as if they are guided by invisible hands, following a cosmic map we are only beginning to decipher. Their approach is subtle, initially appearing as faint glimmers against the backdrop of distant stars. But with modern telescopes and sensitive detection algorithms, their paths have been carefully tracked, revealing the extraordinary reality: a procession of interstellar travelers moving in tandem with 3IATLAS. The questions multiply as we consider the possibilities. Are these objects fragments torn from a single parent body? Could they be remnants of a disintegrated comet from a distant system, sent scattering across space, yet loosely following the same path? Or are they entirely separate entities, independently ejected from different star systems, now converging along similar trajectories by coincidence. Each possibility carries profound implications for our understanding of interstellar dynamics, the formation of planetary systems, and the mechanisms that propel objects across vast cosmic distances. The swarm itself is composed of numerous small bodies, each varying in size, composition, and structure. Some may be icy fragments, akin to miniature comets, while others could be rocky or metallic, remnants of planetary formation processes elsewhere in the galaxy. As they approach the Sun, their interactions with solar radiation and the gravitational pull of our star begin to subtly alter their courses, bending their paths in a delicate celestial dance that is invisible to the naked eye, yet detectable to the most precise instruments. Observing this swarm is a delicate endeavor. Unlike the single, bright object of 3IATLAS, the swarm consists of smaller, fainter objects. Detecting them requires highly sensitive instruments capable of discerning minute movements against the bright tapestry of stars. Each object's trajectory must be carefully measured, every deviation noted. Their velocities, slightly differing yet remarkably consistent with one another, suggest a shared origin or a linked cosmic journey that spans light years. The discovery of a swarm raises fascinating questions about the nature of interstellar travel. In our solar system, comets and asteroids tend to move along predictable paths, influenced primarily by the sun's gravity. But these interstellar travelers are different. They are free agents of the galaxy, moving independently, yet now apparently connected in a loose, mysterious formation. Scientists are beginning to theorize about the forces that may have guided them, perhaps gravitational interactions with distant stars, or the remnants of a shared event in a far-off system, such as a planetary collision or a supernova sent them careening through the void along parallel trajectories. As the swarm draws closer to our Sun, its members will undergo a transformation akin to that experienced by 3IATLAS. The Sun's radiation may heat their icy surfaces, causing outgassing and forming faint tails of gas and dust that stretch into space. Each object's response will be unique, dependent on its composition and structure, yet together they will form a ghostly procession, a shimmering, transient path marking their journey through the inner solar system. For the observer, there is a subtle beauty in this phenomenon. The swarm is not just a collection of objects. It is a narrative written across light years of space, a story of creation, collision, and cosmic motion. As we track these travelers, we are not merely recording data. We are witnessing the choreography of interstellar dynamics in real time. Each fragment carries information about its origin, about the distant systems from which it was ejected, and about the physical processes that govern interstellar travel. And so, we watch and wait. The swarm follows, just behind 3IATLAS, racing silently through the darkness, moving toward the Sun and the light of our solar system. They are messengers from afar, each carrying whispers of worlds we may never visit, hints of cosmic events that shaped distant stars, and clues about the nature of matter traveling through the void. Their approach is a reminder of the richness of the universe, of the intricate connections between distant points in space, and of the endless mysteries that unfold quietly beyond our perception. As you listen now, allow your mind to drift alongside the swarm, following their course through the silent reaches of space. Picture the dark expanse, punctuated by distant stars, as these objects trace invisible arcs, moving with intent, yet guided by forces we are only beginning to comprehend. Feel the calm rhythm of their motion, the gentle pull of the sun drawing them ever closer, and let the subtle mystery of this cosmic procession soothe your thoughts as we continue our journey into the unknown. Interstellar origins. As we follow the swarm trailing 3IATLAS, our minds naturally drift to a profound question. Where did these mysterious visitors come from? Each fragment, each icy or rocky body, has traveled unimaginable distances to reach our solar system, and their origin is a story written across the vast tapestry of the galaxy. To understand them is to peek into the workings of other star systems, to glimpse the forces that shape worlds light years away, and to touch ever so gently the boundless history of the cosmos. The idea of interstellar objects is, in itself, astonishing. These are not bodies formed within our own solar system, where we have studied the planets, moons, and comets for centuries. No, these travelers have journeyed across the silent void, untouched by our sun's gravity until their recent approach. They originate from distant star systems, likely ejected by gravitational interactions with massive planets, stellar collisions, or even the explosive end of a star. Some may have been born in icy belts at the outer edges of alien planetary systems, while others might be fragments of worlds destroyed long ago, propelled into the void at incredible speeds. The swarm following 3IATLAS offers a unique window into these distant processes. Each object carries chemical fingerprints and structural characteristics forged in alien environments. The composition of the swarm, whether icy, rocky, or a mixture, hints at the conditions in other planetary systems. Perhaps they formed in frigid outer regions, where volatile ices remain stable over eons, or in warmer regions where collisions and heating shaped their rocky cores. By studying these interstellar travelers, we can compare them with comets and asteroids from our own solar system, looking for similarities and differences, tracing the universal threads that link the galaxy together. One of the most compelling aspects of these objects is their sheer endurance. Imagine a small fragment of rock or ice cast out from a distant star system, wandering through interstellar space for millions, perhaps billions, of years. Alone in the emptiness, it drifts past the birthplaces of stars, the remnants of long-dead planets, and the invisible streams of cosmic radiation that pervade the galaxy. And yet, despite all these hazards, it arrives here, in our solar system, precisely along a path that allows us to observe it, to learn from it, and to marvel at its journey. The mechanism that sends these objects across the stars is as fascinating as the objects themselves. Within their original star systems, massive planets may act as gravitational slingshots, flinging smaller bodies outward at incredible speeds. In other cases, stellar explosions, such as supernovae, can eject fragments into interstellar space, imparting enough energy to escape their home system entirely. Over time, the fragments traverse the galaxy, influenced only by the faint gravitational tug of stars, drifting silently until they encounter a system like ours. Each encounter is a rare alignment, a cosmic coincidence that brings these distant travelers into our view. Astronomers studying the swarm use its trajectory to infer its origin. By tracing back the path of each fragment, they attempt to map the journey across light years, calculating the velocity, angle of approach, and potential origin systems. While uncertainties remain, the patterns suggest a shared ancestry for the swarm. These are not random wanderers. They may be fragments of the same parent body, separated during a cataclysmic event, now following roughly parallel courses toward the Sun. The concept of interstellar objects challenges our perception of isolation. Our solar system, often imagined as a solitary island in the galaxy, is actually part of a cosmic network, where materials and objects move between star systems, linking distant worlds in ways we are only beginning to understand. Each fragment in the swarm is a tangible reminder of this interconnectivity. Their presence tells us that the galaxy is not a static backdrop, but a dynamic, flowing system where objects can traverse vast distances and bring information from one star system to another. As the swarm approaches the sun, we are witnessing the culmination of an extraordinary journey. It is a journey that began long before our planet existed, long before the Earth was formed from cosmic dust and gas. These fragments carry with them the stories of alien systems, histories of formation, collision, and ejection that allow us to glimpse the conditions and processes that exist light years away. By observing their behavior, astronomers hope to learn not only about the objects themselves, but also about the broader dynamics of planetary systems across the galaxy. For the listener, there is a certain calm in contemplating this vastness. Imagine the silent glide of these objects through the dark void, unbound by the familiar pull of our sun, until they reach the outer edges of the solar system. Feel the gentle inevitability of their path, guided by gravitational forces and cosmic momentum, converging on the sun. Let the mind wander along with them, across unimaginable distances, through the emptiness of space, to the origins of the galaxy itself. And so, as we follow the swarm, let us remember that each object is a story, a fragment of a world we may never see, a messenger from the distant past, and a reminder that the universe is vast, interconnected, and full of wonders yet to be discovered. Tonight, we drift alongside these travelers, our imagination tracing their path, while our minds absorb the quiet lessons of their interstellar voyage. Speed and trajectory, racing the sun. As the swarm of interstellar fragments continues its silent journey, one of the most fascinating aspects emerges: their speed. These objects, following 3IATLAS into our solar system, are moving at velocities that defy everyday imagination. While we might think of comets or asteroids as slow, drifting travelers across the night sky, interstellar objects have a momentum built over millions of years, shaped by the gravity of their distant star systems and the vast, empty void they traverse. Their approach toward the sun is swift, calculated, and governed by the immutable laws of physics. Consider the trajectory of a single fragment. In interstellar space, far from the gravitational influence of any star, it drifts along a straight path, uninhibited, unhurried. Yet, as it approaches the sun, the solar system exerts its influence. Gravity, a silent but powerful force, begins to bend its path. The object accelerates, picking up speed as it draws closer, its hyperbolic trajectory curving like a gentle arc across the dark canvas of space. Unlike comets that orbit the sun in predictable ellipses, these interstellar travelers are on a one-way journey, moving too fast and too dynamically to be captured by the sun's gravity. Their paths are fleeting, beautiful, precise, and transient. The swarm's movement is not uniform. Each fragment has a slightly different speed, a subtly unique path, yet they all share a general alignment with 3IATLAS. Astronomers carefully track these trajectories, noting the influence of the sun, the planets, and even the solar wind, a stream of charged particles constantly emitted by our star. This wind interacts with small, icy fragments, slightly altering their course and shaping their tails if they outgas as they heat up. These minute effects, imperceptible to the naked eye, are vital clues that scientists use to understand the physical properties of these visitors. The speed of these objects is staggering, Some are moving at tens of kilometers per second relative to the Sun, a velocity that allows them to cross the distance from the outer solar system to the inner regions in mere weeks or months. To put this into perspective, Earth itself travels around the Sun at roughly 30 kilometers per second. These interstellar fragments are moving even faster, propelled by forces and events from their origin star systems, making their approach both urgent and mesmerizing. The trajectory of the swarm also reveals the subtle choreography of cosmic forces. Gravity acts as the primary sculptor, bending paths, accelerating objects, and shaping the swarm's overall pattern. Yet it is not the only influence. Solar radiation exerts a pressure that can alter the course of the smallest fragments. The solar wind interacts with outgassing material, creating tails that point away from the Sun and slightly nudging objects along new paths. These interactions are delicate, almost imperceptible, yet when observed over time, they reveal a complex ballet of forces acting across vast distances. Tracking these velocities and trajectories requires precise instruments and careful calculations. Ground-based telescopes, space observatories, and automated survey networks monitor the positions of these objects night after night. Every tiny deviation, every shift in brightness helps astronomers refine their models. Predicting the path of a single fragment is a challenge. Tracking an entire swarm, with each object moving independently, yet following a shared trajectory, is a task that combines human ingenuity with the most advanced technology available. The swarm's race toward the Sun also offers insights into the timing and alignment of interstellar arrivals. These objects are not randomly scattered across the galaxy. Their synchronized approach suggests a shared origin or an event that casts them into space in roughly the same direction. Perhaps a collision in a distant planetary system, or the gravitational ejection from the outer reaches of a star system sent these bodies on parallel courses across interstellar space, converging on our solar system after millions of years of silent travel. As they accelerate, the swarm becomes increasingly visible to our instruments. Subtle glimmers of reflected sunlight appear, growing brighter as the objects approach. If any contain volatile ices, the Sun's heat will cause them to sublimate, forming delicate comas and faint tails that stretch into space. The interplay of speed, trajectory, and solar influence creates a mesmerizing, dynamic scene, a silent, radiant race that unfolds on a scale far beyond human perception. For the listener, imagining this race is a calming yet awe-inspiring experience. Picture the swarm moving with quiet determination, each fragment a tiny traveler from another star system, guided by gravity, propelled by momentum, and sculpted by cosmic forces. Feel the gentle pull of the Sun, drawing these visitors closer, shaping their paths, and creating a fleeting celestial ballet in the silent reaches of space. The swarm's velocity is more than a measurement. It is a story of interstellar travel, a testament to the distances and forces that shape our galaxy. Each fragment's path carries the history of its journey, the conditions of its home system, and the subtle interactions with the universe it has crossed. As we follow their race toward the Sun, we are witnesses to an event that is at once scientific, cosmic, and poetic, a reminder of the immense scale and beauty of our universe. In this moment, as the swarm draws nearer, allow your mind to drift alongside them. Visualize their paths, the invisible curves traced by gravity, and the faint light of their approach as it travels across space. Let the rhythm of their movement, silent yet precise, create a sense of calm and wonder. This is the speed and trajectory of interstellar wanderers, objects that have crossed the galaxy to reach the sun, offering us a glimpse into worlds beyond our own. Observing the swarm. As the swarm of interstellar fragments moves steadily along the path traced by 3IATLAS, astronomers turn their eyes, instruments, and minds toward observation. Observation is both a science and an art, a careful combination of technology, patience, and intuition. These fragments are not ordinary objects. They are visitors from the depths of interstellar space, carrying with them histories, compositions, and motions that are entirely foreign to our solar system. To watch them is to watch a story unfold, written across the night sky in silence, light, and motion. Tracking the swarm is no simple task. Unlike a single bright comet, the swarm is composed of multiple smaller objects, each moving independently, yet following a roughly aligned trajectory. Detecting them requires instruments capable of perceiving the faintest glimmers of reflected sunlight against a backdrop of countless stars. Advanced ground-based telescopes, robotic survey networks, and space-based observatories combine their capabilities to monitor these tiny celestial wanderers, recording their paths night after night and capturing subtle shifts in speed or brightness that may reveal their composition and structure. Each fragment presents its own challenge. Some are icy, emitting faint tails of gas and dust as they warm under the sun's rays. Others are rocky, reflecting little light, almost invisible except to the most sensitive instruments. The swarm, when viewed collectively, is a delicate, moving constellation, each object tracing a silent path toward perihelion, the closest approach to the sun. Their positions, velocities, and brightness are meticulously logged, forming a data set that allows scientists to analyze their behavior, predict their trajectories, and infer their physical properties. Astronomers use a combination of methods to observe the swarm. Optical telescopes capture reflected sunlight, revealing size, shape, and surface characteristics. Infrared imaging provides clues about the temperature and composition of the objects, detecting heat emitted from surfaces warmed by the sun. Spectroscopy, the study of light split into its component colors, offers insights into chemical composition, revealing whether these fragments contain water ice, carbon compounds, silicate rock, or other materials. Each measurement, each observation, builds a more complete understanding of these interstellar travelers. The swarm's observation is also a race against time. Interstellar objects move at incredible speeds, covering vast distances in days or weeks. The window to capture detailed information is brief. Astronomers must act swiftly, scheduling telescope time, coordinating observations across continents, and interpreting data in near real time. Even a slight delay can mean missing crucial moments. When a fragment begins outgassing, when its trajectory bends under solar influence, or when its brightness changes in response to sunlight. Every observation is precious, a fleeting opportunity to study the unknown. Beyond technological challenges, observation is also a story of human curiosity. Astronomers, often working quietly behind screens and lenses, are the eyes through which the universe reveals its secrets. Their careful attention transforms tiny points of light into rich narratives, decoding the past, present, and potential future of objects that have traveled light years to meet us. Each fragment in the swarm carries its own tale, and observing them allows us to piece together the larger story of interstellar travel, celestial mechanics, and the interconnectedness of star systems across the galaxy. The swarm's approach is not just about science, it is also about wonder. Imagine the silent glide of these fragments through the cosmos, each tracing an arc guided by gravitational forces, solar radiation, and momentum imparted millions of years ago in a distant system. By observing them, we do not merely record data. We participate in a cosmic experience, feeling the quiet pulse of the universe as it unfolds before our eyes. Even in the gentle cadence of sleep-friendly narration, there is awe. The sheer scale of space, the speed of these travelers, and the precision with which they move across the dark tapestry of the solar system. Observation also reveals patterns, subtle behaviors that suggest origins. Some fragments appear clustered, hinting at a shared parent body. Others diverge slightly, perhaps shaped by small differences in mass, composition, or the gravitational nudges of passing planets. Tracking these variations allows scientists to build models of the swarm's history, understanding how these objects were ejected, how they traveled through interstellar space, and how they will continue their journey beyond our solar system. As the swarm moves closer to the Sun, observational detail increases. Brightness intensifies, tails lengthen, and subtle outgassing may become visible even to smaller telescopes. The Sun acts as a natural illuminator, revealing the delicate characteristics of these fragments. Every tail, every subtle glimmer of reflected light, provides clues about composition, size, and surface features. It is as though the universe itself is providing a gentle spotlight, inviting us to watch, learn, and reflect. For the listener, there is a meditative quality to these observations. Imagine gazing through a telescope, or even envisioning these objects in your mind's eye. Each fragment moves silently, a traveler from a distant star system, guided by forces beyond human comprehension. Let your thoughts drift with them, tracing their path toward the Sun, feeling the calm inevitability of motion and absorbing the quiet wonder of observing something truly alien, yet profoundly connected to our solar system. The science of observation is therefore both technical and poetic. It requires precision and patience, yet rewards us with beauty, insight, and a sense of connection across the vast expanse of the galaxy. By watching the swarm, we glimpse the dynamic nature of the universe. The remnants of distant systems traveling billions of kilometers to reach our neighborhood, and the incredible persistence of matter moving across interstellar space. Each observation is a whisper from another world, a message carried across light years, inviting us to listen, to learn, and to wonder. Composition and mysteries. As the swarm of interstellar fragments silently follows 3IATLAS toward the Sun, another question comes to the forefront of astronomers' minds. What are these objects made of? Composition is the key to understanding origin, history, and potential behavior, and in the case of interstellar travelers, it is also a window into the workings of distant star systems. Each fragment carries with it a story written in ice, dust, and rock, a tale that began light years away and continues now as it glides through our solar system. The study of composition begins with observation. As these objects approach the Sun, sunlight reflects off their surfaces, revealing subtle differences in brightness and color. Some fragments are icy, resembling the comets we know in our own solar system. These icy bodies may contain frozen water, carbon dioxide, methane, or ammonia, materials that preserve the chemical signatures of their birthplace. Others appear rocky, dark, or metallic, suggesting they may be remnants of larger bodies that fragmented long ago. Each type of material provides clues. Icy fragments hint at cold outer regions of a distant star system, while rocky fragments suggest formation closer to a star, or perhaps violent disruption of a planet or moon. Spectroscopy offers another vital insight. By analyzing the light emitted or absorbed by these fragments, astronomers can identify the elements and compounds present. Tiny variations in the spectra can reveal differences in composition between members of the swarm, suggesting whether they originated from a single parent body or multiple sources. It is a meticulous process, but it is one that allows scientists to decipher the silent chemical language carried across the void of interstellar space. As the swarm draws nearer, outgassing may begin for those fragments containing volatile materials. The sun's heat causes ice to sublimate, releasing gases and dust that form ephemeral tails, just as we saw with 3IATLAS. These tails are not only visually striking, but scientifically invaluable. They carry molecules and particles that reflect the conditions of the fragment's formation. By studying the composition of the gas and dust, scientists gain clues about the temperature, pressure, and chemical environment of their original star system. Yet, the swarm is not uniform. Observations indicate subtle differences between fragments. Some display strong outgassing, brightening as they near the sun, while others remain inert, reflecting only sunlight. This variety suggests that the swarm may include objects of different sizes, densities, and compositions, or perhaps fragments that originated from different regions of a parent body. Each variation deepens the mystery, adding layers of complexity to the task of unraveling their story. The composition of these interstellar visitors also raises questions about what we have yet to discover about our own solar system. Are these fragments similar to comets and asteroids we have studied here? Or do they hold exotic materials never seen before? Could they even carry organic compounds or other prebiotic chemicals, hinting at processes that occur in star systems far from our own? These possibilities make the swarm not only a scientific curiosity, but a bridge to understanding planetary formation, chemical evolution, and the broader dynamics of the galaxy. Observing composition is a patient endeavor. Each fragment must be tracked over time, with repeated measurements to confirm findings. Slight changes in brightness, subtle differences in the spectra, and variations in tail formation all contribute to a richer understanding. The closer the fragments come to the sun, the more pronounced these effects become, and the more data astronomers can gather. It is a slow, quiet process, much like the gradual unfolding of the universe itself, a whisper of information traveling across the void, waiting to be captured. For the listener, there is a tranquil beauty in imagining the swarm's composition. Picture icy fragments glinting faintly under the sun's distant light, tiny clouds of gas forming transient tails, and rocky fragments drifting silently, dark and mysterious. Each object is a fragment of another world, carrying the legacy of a distant star system across millions of kilometers of empty space. Visualize them in your mind's eye and feel the calm rhythm of their motion, their silent journey unfolding across the solar system like a slow, cosmic lullaby. The mysteries of composition invite curiosity and wonder. Every measurement, every spectral line, every faint outgassing event is a clue, guiding scientists toward understanding the origins and histories of these fragments. And while we may never fully know the complete story, each observation draws us closer, linking our solar system to distant stars and expanding our knowledge of the galaxy. As we drift with the swarm, it is worth reflecting on the scale of this cosmic journey. These fragments, traveling at incredible speeds across interstellar space, carry within them the materials and histories of worlds we may never see. Their composition is a silent testament to the forces and conditions at work in other corners of the galaxy. And as we continue to watch, to measure, and to learn, the mysteries they carry unfold slowly, quietly, and beautifully, revealing the subtle complexity of the universe and our place within it, the potential risks. As we drift alongside the swarm of interstellar fragments following 3IATLAS, it is natural to wonder, do these visitors pose any threat to our solar system or to Earth itself? While the idea of cosmic objects traveling at incredible speeds toward the sun can spark unease, the reality is both reassuring and enlightening. Studying these potential risks is not only crucial for safety, it also deepens our understanding of the solar system's dynamics and the protective role of gravity and distance. The first point to consider is scale. The fragments in this swarm are small compared to planets, moons, or even larger asteroids. Most are likely only a few meters to a few kilometers across. Despite their diminutive size, they are moving at astonishing speeds, tens of kilometers per second. If one were to intersect with a planet, the energy released could be significant. But the vast distances between objects in space make direct collisions exceedingly rare. Even in the inner solar system, the likelihood of an object colliding with Earth is vanishingly small. The vast emptiness of space is its own safety mechanism, a buffer that keeps celestial travelers mostly at a distance. Yet the study of potential risks is not taken lightly. Scientists use sophisticated models to simulate trajectories, calculate gravitational influences, and predict paths with extreme precision. Each fragment is tracked meticulously, noting how the sun's gravity bends its trajectory and how planetary gravitational fields could nudge it slightly off course. For the swarm, this is a complex puzzle. While each object is on a hyperbolic path, their velocities, positions, and angles of approach are constantly monitored to ensure that no fragment comes dangerously close to Earth or other planets. One of the most fascinating aspects of this monitoring is understanding the subtle influences on these fragments' paths. Solar radiation, the solar wind, and even minor interactions with other fragments can slightly alter trajectories over time. These forces are small, almost imperceptible, yet they can accumulate, subtly shifting paths in ways that require careful observation. Scientists remain vigilant, modeling these influences to predict the swarm's future journey with as much accuracy as possible. It is also worth considering the broader context of interstellar objects in our solar system. While 3IATLAS and its swarm are exceptional for their speed and trajectory, interstellar fragments occasionally pass through the solar system. These rare visits are fleeting, and most of these objects sail past the planets without incident. Yet even their brief presence is valuable. By studying their paths and interactions, we learn not only about potential risks, but also about the dynamics of gravitational forces, orbital mechanics, and the structure of the solar system itself. Observing potential risks is, in a sense, a cosmic rehearsal. Scientists use each new discovery to refine predictive models, to simulate encounters, and to develop strategies that could be used for larger, more threatening objects in the future. This knowledge is essential for planetary defense and for understanding how objects from outside our solar system behave. Each fragment in the swarm, while unlikely to strike Earth, offers data that could one day be applied to protect our planet from hazards both known and unforeseen. For the listener, it is calming to reflect on these risks within the context of the immense distances involved. The fragments are hurtling through millions of kilometers of empty space. Earth is but a small target in a vast cosmic arena. The Sun's gravity and the orbits of other planets act as natural shields, bending paths and creating safe corridors. By observing the swarm, scientists are not only learning about interstellar composition and dynamics, but also confirming that the universe, despite its unpredictability, has an elegant system of balance and distance. Even the thought of potential risks carries a subtle lesson about perspective. These objects have traveled across light years, surviving the emptiness of interstellar space, only to enter the solar system for a brief encounter. Their paths remind us of the fragility and resilience of our planetary neighborhood, of the protective mechanisms inherent in celestial mechanics, and of the importance of careful observation and preparation. The universe may be vast and filled with moving objects, yet through observation, knowledge, and precision, we can understand and anticipate even the seemingly chaotic. As we drift alongside the swarm, imagine the silent calculations performed by scientists, tracking trajectories, predicting outcomes, and analyzing potential interactions. Every observation reassures us, confirming that while the fragments follow 3IATLAS toward the Sun, the risk to Earth is negligible. Yet, their presence enriches our understanding, providing insight into how interstellar fragments behave when they pass through our solar neighborhood. Their journey is both a marvel of motion and a lesson in cosmic balance. Let your mind rest on this delicate equilibrium. Picture the swarm gliding silently, each fragment guided by momentum, gravity, and the gentle nudge of solar radiation. Feel the reassurance that the universe has natural safeguards, and yet marvel at the precision and vigilance required to observe, track, and study these wandering travelers. The potential risks are minimal, but the knowledge gained is immense, a quiet, powerful reminder of the interplay between cosmic motion and scientific understanding. The legacy of 3IATLAS. As the swarm quietly follows in the wake of 3IATLAS, it is impossible to overlook the profound legacy of this pioneer interstellar traveler. 3IATLAS was more than a comet passing through our solar system. It was a messenger from another star system, carrying with it the evidence of a journey across light years of empty space. Its discovery fundamentally changed the way we perceive our place in the galaxy, reminding us that our solar system is not isolated, but part of a larger, interconnected cosmic web. Before 3IATLAS, astronomers could theorize about interstellar objects, but very few had been observed. Oumuamua, discovered in 2017, opened the first door, but 3IATLAS solidified the reality that the universe is full of wandering travelers. It demonstrated that interstellar visitors could be tracked, studied, and understood, even if only briefly during their fleeting passage. And now, the swarm following in its path is an extension of that legacy, a living proof that the universe is teeming with motion, with fragments of distant worlds making their way across the void to reach our attention. The legacy of 3IATLAS is both scientific and philosophical. Scientifically, it provided the first direct opportunity to study the composition, trajectory, and dynamics of an object from another star system. Observations revealed a hyperbolic trajectory, a velocity beyond what is typical for objects bound to our Sun, and a composition that hints at the processes occurring in distant planetary systems. These discoveries expanded our knowledge of what is possible in the galaxy, opening new avenues for research and inspiring technological advancements in detection, tracking, and analysis. Philosophically, 3IATLAS reminds us of the vastness and interconnectedness of the universe. A fragment from a distant star system can traverse light years of emptiness, passing through our solar system for only a brief moment in cosmic time, yet leaving a lasting imprint on our understanding. It is a symbol of cosmic continuity, a reminder that even the smallest fragments can carry profound stories across unimaginable distances. The swarm now approaching the Sun is, in many ways, a tribute to 3IATLAS's pioneering journey. Each fragment traces a path influenced by the same cosmic forces that shaped 3IATLAS. The momentum imparted during ejection from a distant system, the gravitational influences of stars and planets along the way, and the guiding pull of our own Sun. Together, they form a procession that speaks to the broader narrative of interstellar travel, echoing the journey of the comet that first captured our attention. By studying the swarm, astronomers can compare its properties with 3IATLAS, testing models of interstellar object behavior, origin, and composition. Observing differences and similarities helps refine our understanding of how such objects are formed, how they survive the harshness of interstellar space, and how they interact with the solar system upon arrival. 3IATLAS thus serves as both a reference and a benchmark, guiding the interpretation of the swarm's mysteries. For the listener, there is a quiet wonder in reflecting on this legacy. Picture 3IATLAS traveling through the dark void, its tail faintly glowing as it interacts with the solar wind. Imagine the swarm following, smaller but no less significant, each fragment carrying a part of the story, each a testament to the vast and intricate forces shaping the galaxy. As you visualize this cosmic procession, let the calm rhythm of their motion bring a sense of tranquility, blending scientific insight with the quiet awe of witnessing interstellar phenomena. The legacy of 3IATLAS extends beyond individual observations. It inspires curiosity, patience, and the drive to explore the unknown. It has motivated new surveys, refined detection methods, and inspired collaborative research across continents. Its journey, now mirrored by the swarm, reminds us that the universe is alive with motion, with stories waiting to be discovered by those who watch carefully and think deeply. In this chapter, as we drift alongside the swarm and the pioneer comet, allow your mind to absorb both the magnitude and the intimacy of this cosmic narrative. Each fragment, each orbit, each subtle flash of reflected light carries within it the echoes of distant worlds. And as we continue to follow these interstellar visitors, we are participants in a story that stretches across space and time, a story that connects us to the galaxy in ways both profound and serene. 3IATLAS's legacy is therefore a bridge, a connection between past discoveries and present exploration, between our solar system and the distant stars from which these objects originate. It is a reminder that even in the vast emptiness of space, there is order, continuity, and a story unfolding that we are privileged to witness. And as the swarm follows, that story grows richer, deeper, and more extraordinary, offering insight, inspiration, and a gentle sense of cosmic wonder. The bigger picture, galactic connections. As we continue to drift alongside the swarm following 3IATLAS, we are reminded that these objects are not isolated travelers. They are part of a much larger cosmic tapestry. Each fragment, each comet or asteroid from interstellar space represents a connection between star systems, a physical thread linking distant worlds across the vast expanses of the galaxy. In observing them, we begin to perceive the bigger picture, a universe alive with movement, interaction, and subtle connectivity that transcends the boundaries of any single solar system. Our solar system is often imagined as a solitary neighborhood, with planets, moons, and comets orbiting peacefully around the Sun. Yet the passage of 3IATLAS, and now the swarm following it, reminds us that the Sun is just one star among billions in the Milky Way, and that material can travel between stars, carrying with it information about conditions in far-off systems. These interstellar visitors are messengers, delivering fragments of other star systems into our cosmic backyard and offering clues about planetary formation, chemical composition, and the history of their origins. Each fragment in the swarm provides a unique opportunity to study galactic dynamics. By tracing their trajectories backward, astronomers attempt to estimate their points of origin, identifying regions of the galaxy that could have ejected them. Some may have been flung out by gravitational interactions with giant planets, others by stellar explosions, collisions, or the chaotic evolution of planetary systems. Their presence in our solar system allows us to connect the dots, to reconstruct a journey across light years, and to understand the interconnectedness of celestial mechanics on a galactic scale. The swarm also highlights the diversity of interstellar objects. Just as 3IATLAS revealed surprises in composition and behavior, the fragments following in its path offer further insights. Variations in size, reflectivity, chemical makeup, and trajectory suggest that interstellar space is filled with an astonishing variety of materials, shaped by countless star systems over billions of years. Each fragment is a miniature archive, preserving the history of its birthplace and offering the potential to compare alien environments to the solar system we know. Observing these galactic connections requires both precision and patience. Scientists meticulously track the swarm, measuring speeds, angles, and brightness, noting the effects of solar gravity and radiation. The interplay of forces that shapes their paths is subtle yet profound, reflecting the invisible threads that link the stars. In doing so, astronomers are not only mapping the trajectory of each fragment, but also mapping the broader structure of our galaxy, one interstellar visitor at a time. For the listener, imagining these connections is a gentle exercise in cosmic perspective. Picture the swarm moving silently, billions of kilometers from Earth, yet tethered invisibly to distant stars, traveling paths dictated by gravity, momentum, and chance. Visualize 3IATLAS leading the way, with fragments following as if tracing a cosmic blueprint. These journeys are reminders that the universe is a web of motion and interaction, where even objects that seem solitary are part of an intricate, interconnected system. The bigger picture is not just about motion, it is about context, scale, and significance. The solar system is a small node in a galaxy teeming with activity. Interstellar fragments like the swarm remind us that what we observe locally is connected to processes occurring on vast scales. The collisions, formations, and ejections of distant star systems have consequences that echo across light years, eventually bringing tiny travelers to our attention. In this way, we begin to appreciate not only the beauty of their motion, but the deep interconnectivity of the cosmos. As the swarm continues its approach, we are invited to consider both the microcosm and the macrocosm. Each fragment is an individual story, a journey across the void. Together, they form a pattern that connects stars, systems, and galaxies. By observing them, studying their trajectories, and understanding their composition, we gain insight into the grand narrative of the galaxy, a story of motion, evolution, and interstellar communication that unfolds silently over billions of years. And so, as you drift with this narration, imagine yourself floating alongside these interstellar travelers. Feel the calm rhythm of their approach, the invisible currents of gravity guiding them, and the subtle interplay of forces that shape their paths. Let your mind absorb the vastness, the connectivity, and the delicate balance of motion that links distant star systems with our own. The bigger picture is one of wonder, continuity, and cosmic harmony, a gentle reminder of the grandeur of the universe and the quiet beauty of interstellar exploration, the science for sleep experience. As the swarm follows 3IATLAS toward the sun, it is easy to become absorbed in the science, the measurements, and the trajectories. Yet, there is another way to experience this journey, a way that is gentle, meditative, and perfectly suited for quiet reflection or sleep. This is the essence of the science for sleep experience, blending scientific wonder with a calm, soothing narrative, allowing listeners to drift through the cosmos without tension or haste. Imagine floating alongside these interstellar fragments. Each one glimmers faintly in the distance, catching sunlight and reflecting it across the silent void. The motion is deliberate yet gentle, a smooth, flowing path shaped by gravity and momentum over millions of years. The sun's warmth begins to touch the fragments as they approach, and for those that contain ice, faint trails of gas drift outward, forming ephemeral tails that shimmer subtly against the backdrop of countless stars. The entire scene is quiet, serene, and hypnotically rhythmic, a celestial lullaby that invites relaxation. The experience of observing the swarm is enhanced by understanding the forces at work. Gravity bends paths, solar radiation influences rotation, and the solar wind gently nudges icy fragments. These are subtle, almost imperceptible effects, yet they create a dynamic, living scene, a silent choreography across the emptiness of space. As you visualize this, let your mind trace the delicate curves of each trajectory, the faint glow of material sublimating under the sun's influence, and the harmony of motion that binds these objects together. Listening to this journey allows the mind to drift along with the swarm. You can imagine the fragments gliding silently past planets, weaving through the sun's gravitational field, and stretching tails of gas into the void. The perspective is both vast and intimate. Vast in scale, as you contemplate the distances traveled and the time elapsed, yet intimate in detail, as you notice the light glinting off a fragment or the faint curve of a tail. This duality is at the heart of the science for sleep approach, marrying curiosity with calm, wonder with relaxation. For those who enjoy stargazing or reflecting on the universe before sleep, this experience is particularly powerful. The narration acts as a guide, gently leading the mind through space without urgency. Each sentence is paced slowly. Each observation is layered with descriptive imagery, and each pause allows the listener to absorb the scene. The rhythm of words mirrors the quiet flow of the swarm, creating a meditative environment that fosters both understanding and relaxation. The scientific narrative continues alongside this immersive experience. By understanding the nature of interstellar objects, their origins, trajectories, and interactions, you gain insight into the cosmos while your mind drifts gently along with it. The calm narration, combined with the vast, silent backdrop of space, allows for a unique form of contemplation, where learning and rest coexist. You explore the universe, not in haste or urgency, but in quiet, deliberate motion, following 3IATLAS and its companions as they trace paths shaped over millions of years. And so, as you settle deeper into this journey, picture yourself among the stars. Feel the gentle pull of gravity, the soft radiation of the sun brushing past the fragments, and the silent, eternal rhythm of motion that guides the swarm. Let curiosity blend with calm, wonder with relaxation, and science with serenity. This is the Science for Sleep experience, a voyage through interstellar space that nourishes both the mind and the imagination, gently guiding you toward peaceful contemplation and ultimately toward sleep. The journey continues. As we reach the final chapter of our journey alongside 3IATLAS and its trailing swarm, we are left with a profound sense of wonder, reflection, and serenity. The swarm has passed through our solar system, silently tracing paths shaped by gravity, momentum, and the subtle forces of the sun's radiation. Each fragment has been a messenger, carrying the history of distant star systems across the void of interstellar space, reminding us that the universe is vast, interconnected, and constantly in motion. In observing these celestial travelers, we gain far more than knowledge. We gain perspective. Each fragment, moving billions of kilometers from its origin, speaks to the vast distances that separate stars, the immense timescales over which the cosmos evolves, and the delicate precision required for a small body to traverse the galaxy and enter our solar neighborhood. Their journey is a testament to the forces that govern our universe, and to the silent, invisible threads connecting distant worlds. The significance of this swarm extends beyond mere observation. By studying their speed, composition, and trajectories, astronomers refine our understanding of interstellar physics, planetary formation, and the chemical makeup of distant systems. They illuminate the hidden architecture of the galaxy, showing us how objects are ejected, accelerated, and guided through the void. And for those of us observing in thought or imagination, it is a reminder of our place within this grand cosmic dance. A small but conscious presence witnessing the unfolding of distant events across light years. There is also a quiet lesson in patience and attention. These objects, traveling for millions of years, arrive briefly before moving onward, disappearing back into the emptiness of space. Our window of observation is short, yet through careful study, meticulous tracking, and calm, deliberate observation, we can capture enough of their story to learn, wonder, and reflect. The swarm is a fleeting phenomenon, but the knowledge it imparts is enduring, a bridge between distant stars and our own solar system. For the listener, this is a moment of gentle reflection. Imagine the fragments fading into the depths of space, the trails of their tiny tails lingering faintly in the sunlight, and the paths they traced still subtly, influencing the broader motion of objects in the solar system. Feel the calm rhythm of the universe, the silent hum of gravitational interactions, and the quiet beauty of a cosmic journey that has spanned light years to arrive at this moment in time. As we conclude this exploration, it is worth considering the endless possibilities that lie ahead. Today, it is 3IATLAS and its swarm. Tomorrow, it may be another interstellar visitor, another fragment, or a completely unknown phenomenon. The universe continues its motion, silent and eternal, offering a perpetual invitation to observe, to learn, and to marvel. Each discovery builds upon the last, expanding our understanding and our imagination, and offering new opportunities to drift through the cosmos with curiosity and calm. Let your mind linger on this journey for a few moments longer. Picture the swarm moving outward, leaving the solar system behind, and consider the countless other travelers crossing the galaxy unseen, each carrying information about distant stars, planets, and histories beyond our own. Let the quiet rhythm of their movement soothe you, blending scientific insight with imagination and allowing the mind to settle in gentle reflection. And finally, as you drift off, remember this: The journey of 3IATLAS and its companions is never truly over. It continues silently through the galaxy, a cosmic story unfolding across space and time. And in witnessing it, even for a brief moment, we become part of that story. We are observers, participants, and dreamers, connected to the universe in ways both profound and serene. The journey continues, not just for the swarm, but for all of us who watch, listen, and imagine. And with that, we can rest, comforted by the knowledge that the cosmos is vast, dynamic, and full of wonder, inviting us to return whenever curiosity calls.